Every second, a star 400 times wider than Earth breathes out light and energy into the void. It burns without pause, shaping every world it touches. From a distance, we call it the sun, but to understand it is to look directly into the heart of existence itself. For most of human history, the sun was unknowable. Too bright to stare at, too dangerous to observe, too powerful to touch. We felt its warmth, we feared its storms, and we built our calendars around its rhythm, but we never truly saw it. Until now. Scene 1. The quest to see the unseeable. In 2010, NASA launched a spacecraft with a single purpose: to watch the sun every second, every day, without blinking. It was called the Solar Dynamics Observatory, or SDO. Orbiting Earth at 22,000 miles, it carried instruments so precise they could record a single wavelength of light invisible to human eyes. From that vantage point, the SDO became humanity's permanent witness to the sun's life. It captures an image every 0.75 seconds, painting an endless portrait of plasma, magnetic storms, and atomic fire. For the first time, we could see not just a burning disk, but a living, breathing system of loops, flares, and waves, a dynamic ocean of light. Scene 2. The surface that isn't a surface. What we call the sun's surface doesn't actually exist. It's a layer of gas so hot that atoms break apart into ions and electrons, a plasma so dense with motion it behaves like liquid flame. Here, temperatures reach 5,500 degrees Celsius, yet only a few hundred kilometers above, the temperature skyrockets to 1,000,000 degrees. That paradox, why the outer atmosphere is hotter than the surface, is one of the great unsolved mysteries of astrophysics. The SDO was built to study that mystery, to see the invisible bridges of magnetism that transfer energy from the sun's body to its halo, the corona. Every swirl, every flare, every pulse of light is a clue, evidence of magnetic fields twisting and snapping in patterns of unimaginable power. Scene 3. The Symphony of Light. The SDO observes the sun in multiple wavelengths of ultraviolet light, each revealing a different layer of its atmosphere. At 171 angstroms, we see elegant arcs of magnetic plasma. At 304 angstroms, rivers of helium glow in soft red ribbons. At 335 angstroms, the hottest regions blaze electric blue. Together, they form a symphony, each wavelength a separate instrument, each frame a note in an endless song of fusion and motion. What our eyes perceive as light is actually 1,000 invisible harmonies layered together. The SDO allows us to hear them all through vision. Scene 4. The Language of Magnetism. The sun's true architecture is written in magnetism. Under the surface, turbulent convection drags magnetic fields into knots. When these knots snap, they release energy equivalent to billions of nuclear bombs, an eruption of radiation and charged particles hurled into space. These are solar flares, and when they align with Earth, they can ignite auroras, disrupt satellites, even threaten power grids. But for the SDO team, each flare is also a heartbeat, the pulse of a living star. By tracking these magnetic signatures, scientists can forecast solar storms days before they reach Earth, turning chaos into prediction and danger into knowledge. Scene 5. The Eye and its Mirror. Every few years, the SDO's orbit aligns perfectly between the Sun and Earth. For a brief moment, our planet casts a circular shadow across the spacecraft's camera, a solar eclipse seen from space. During those minutes, the sun's face darkens, and the SDO captures the event in astonishing clarity, a cosmic heartbeat of light and darkness. Even in silence, the sun is never still. It shifts, pulses, trembles. It breathes in magnetic waves and exhales light that travels 8 minutes to reach us, a fragile, constant connection between star and planet. Scene 6. The scale of the impossible. Every second, the sun converts 600 million tons of hydrogen into helium. In that fusion, 4 million tons of matter vanish, transformed entirely into energy. That single second releases more power than humanity has produced in its entire history. Yet the sun is efficient. Even after 5 billion years, it's only halfway through its life. To SDO's cameras, this longevity appears as rhythm. Sunspots appearing and fading in an 11-year cycle, like seasons of magnetism written in plasma and fire. Each sunspot marks a storm larger than Earth. Each cycle renews the star's energy and reshapes the solar system's weather. Scene 7. What we've learned. From the SDO's decade-long watch, we've learned that the sun is not constant. It's a restless engine, a balance between gravity pulling inward and radiation pushing outward. We've seen coronal loops twist like braided ropes, flares erupt from nothing, and shock waves ripple across the surface at hundreds of kilometers per second. We've measured the sound waves trapped within, the deep vibrations that let us listen to the sun's interior. Through this data, we're discovering that the sun behaves much like a heartbeat, sometimes steady, sometimes erratic, but always alive. For thousands of generations, we looked up and saw mystery. Now, for the first time, we see motion, structure, logic. And yet, the closer we look, the more we realize how little we truly know. Scene 8. Transition to the deeper layers. Beyond the corona lies another frontier, the space where the sun's breath becomes wind, where magnetic storms shape the planets, and where light itself is born from the roar of fusion. To explore that realm, we must dive even deeper into the star itself.
In Part 1, the Solar Dynamics Observatory opened our eyes to the sun's living surface, to the magnetic loops, the flares, and the waves that never cease. Now, we go inward, into the layers of fusion and flow that power every breath of light. Scene 1. Beneath the visible flame. Beneath the glowing photosphere lies a vast region of boiling gas called the convection zone. Here, hot plasma rises, cools, and sinks again, billions of times a second. Each cell of motion is larger than continents, and each carries energy upward like a tide of fire. SDO cannot see this layer directly, but it listens. By measuring subtle ripples in the sun's brightness, scientists read the vibrations traveling through it, sound waves crossing 500,000 kilometers of plasma. From those oscillations, they map currents, revealing a hidden circulation that turns the entire sun like a wheel. Scene 2. The furnace of creation. Deeper still lies the core, where temperature climbs to 15 million degrees Celsius and pressure crushes matter into fusion. Here, hydrogen nuclei merge into helium, releasing light that will take hundreds of thousands of years to reach the surface.
Every photon we see began as a spark in this core long before humanity existed. By the time it reaches our eyes, it has bounced through countless atoms, changing direction 1,000,000,000,000 times. A slow pilgrimage from the center of a star to the sky above our world. When you stand in sunlight, you are being touched by ancient light. Scene 3. The pattern of power. The SDO's data helped confirm how energy from the core flows outward in layers, first by radiation, then by convection, and finally as visible light. That pattern isn't just physics, it's rhythm, a steady, pulsing heartbeat that keeps the solar system alive. Every planet, every moon, every life form depends on that rhythm remaining constant. If the sun faltered for even a few percent, oceans would freeze or boil. Yet, for 5 billion years, it has remained astonishingly stable. The SDO's long watch allows us to see the small fluctuations that shape climate and to understand the balance that makes our existence possible. Scene 4. The magnetic soul. Inside the sun, motion and magnetism are one. Charged plasma flows create magnetic fields, and those fields in turn guide the plasma. Together, they build colossal loops that arch thousands of kilometers into space, the structures we see in SDO's ultraviolet imagery. These loops twist, reconnect, and sometimes snap, releasing bursts of X-rays and particles known as coronal mass ejections. Each eruption can span more than 100 Earths across and travel through the solar system at millions of kilometers per hour. When these storms reach us, they can ripple through our planet's magnetic field, lighting auroras in the polar sky and briefly turning night into color. Scene 5. The breath of the star. The sun is constantly shedding material, a thin stream of charged particles called the solar wind. This wind shapes a vast bubble around our solar system known as the heliosphere. SDO's observations of the corona reveal where that wind begins, in dark regions called coronal holes, where magnetic field lines open into space. Through those windows, the sun exhales. Its breath carries energy to every corner of the solar system, protecting us from interstellar radiation, yet reminding us how fragile our magnetic shelter really is. In every pulse of the sun's wind, we can trace the story of our own survival. We orbit within its protection, bathed in its light, shaped by its storms. To study the sun is to study the boundary between life and oblivion. Scene 6. Seeing the unseen. The SDO doesn't see light the way we do. Its cameras observe wavelengths our eyes cannot, the ultraviolet and extreme ultraviolet glow of million-degree plasma. To visualize this, scientists assign colors to each wavelength: gold for 171A, red for 304A, teal for 193A. The result is not artistic exaggeration, but translation, a way to make the invisible visible. What we see in those 4K images are true motions: loops folding, filaments collapsing, flares twisting like ribbons of electric liquid. Each frame is a real moment, recorded in perfect detail by a satellite that never blinks. Scene 7. The rhythm of cycles. The sun moves through an 11-year magnetic cycle. At solar minimum, its face is calm, with few sunspots and gentle radiation. At solar maximum,
Its surface seethes with storms, magnetic fields reversing polarity, sunspots multiplying in chaotic beauty. SDO has now watched more than a full cycle, giving us the most complete visual record in human history. Through that cycle, we see not just energy, but balance, creation and destruction intertwined in constant renewal. Scene 8. The paradox of the corona. Even after decades of study, one question remains. Why is the corona so much hotter than the surface beneath it? It's as if the air above a flame burns hotter than the flame itself. SDO's high-speed imaging shows microflares, tiny, rapid bursts of magnetism occurring all across the corona. Individually small, collectively immense, they may be the hidden engines heating that outer atmosphere. It's a reminder that sometimes the greatest mysteries hide in the smallest motions. Scene 10. The Sun's pulse and Earth's response. Every solar storm that reaches us begins as a spark recorded by SDO. By comparing those moments to their effects on satellites and radio networks, scientists have learned to forecast space weather hours or days in advance. It's the first step towards solar climate science, understanding how the sun's moods shape our technology, our navigation, even our power grids. For a civilization built on electronics, the sun is both parent and potential threat. Knowledge is our shield. Scene 11. Transition toward the outer light. After more than a decade of unbroken observation, the SDO has given us a portrait of the sun not as a static star, but as a restless being, a fusion of order and turbulence. Yet what happens when that energy leaves the sun entirely? When light and wind travel outward through the solar system, touching each planet in turn. To follow that journey, we must leave the sun's surface and chase its light across space.
In Part 2, we ventured into the sun's heart, the furnace of fusion, the storm of magnetism, the source of everything we call light. Now we trace that light as it leaves home, carried outward as a breath, a storm, and a song that fills the solar system. Scene 1. The long reach of light. From the instant light leaves the sun's surface, it begins a journey of over 150 million kilometers to Earth. It travels that distance in just over 8 minutes, crossing a cosmic bridge that connects us directly to the heart of a star. Every sunrise is the end of that journey, a photon completing its ancient flight. And though we rarely think of it, that light is the most constant message the sun sends. I am here. I am still burning. The Solar Dynamics Observatory captures not just the light itself, but the rhythm in which it is born, the pulses and storms that travel alongside it. Through that lens, we see the solar system as one vast web of energy, woven by the same light that gave us life. Scene 2. The breath of a star. The sun does not shine alone, it breathes. From its corona flows the solar wind, a river of charged particles, mostly electrons and protons, traveling outward at up to 800 kilometers per second. This wind fills a bubble around our solar system, known as the heliosphere, a shield of magnetic force that protects us from the harsh radiation between stars. Inside that bubble, every planet, every comet, every atom of dust feels the sun's breath. Its wind shapes the tails of comets, carves magnetic patterns across Mars, and lights Earth's poles with auroras that dance like liquid fire.
The SDO helps scientists trace where that wind begins, in the dark gaps of the sun's corona, where magnetic lines open into infinity. Scene 3. The solar connection. The solar wind does more than move particles. It connects every world to the sun through magnetism. Earth's magnetic field captures some of this energy, guiding particles toward the poles. When they collide with our upper atmosphere, oxygen and nitrogen release light, green, red, and violet ribbons glowing against the night. These auroras are not just beauty, they are dialogue, a silent conversation between our planet and the star that sustains it. Even the storms that threaten satellites and power grids are part of this communication. Each disruption, each flare, reminds us of our dependence, that Earth is never separate from the sun, but part of its living system. Scene 4. The storms of space. At times, the sun's calm face gives way to fury. Magnetic fields tangle and snap, releasing massive flares and coronal mass ejections, or CMEs. When one of these eruptions is directed at Earth, it compresses our magnetic field like a drum. Currents surge through the ionosphere. Radio signals fade, satellites shudder, and high above, the auroras erupt in breathtaking brilliance. In 1859, a flare known as the Carrington event triggered telegraph fires across continents. If such a storm struck today, it could disable power grids, disrupt navigation, and darken cities for weeks. That is why SDO's mission is not only scientific, it's protective. By observing the sun's smallest changes, we can foresee its largest storms. Narrator. We used to think of space as silence. Now we know it is full of weather, storms and winds, pressure and flow. And every forecast begins 150 million kilometers away. Scene 5. The light that shapes planets. Every world in our solar system has been sculpted by sunlight. Mercury, burned and scarred by heat. Venus, its atmosphere thickened by runaway greenhouse effect. Mars, once warm, now frozen and dry. Even distant Pluto shows traces of sunlight's influence, a thin atmosphere that freezes and returns as it orbits, breathing in rhythm with the faint light that reaches it. SDO's data gives scientists the foundation to understand all these processes, the balance between energy received and energy lost. In that sense, every planet's climate is a reflection of its distance from the same fire. Scene 6. The fragile balance of Earth. On Earth, that balance is perfect, for now. Our world orbits within the narrow band where water can exist as liquid. Too close, and oceans would boil. Too far, and they would freeze. The sun's light has remained stable enough for life to emerge, but even small variations influence our climate over centuries. By studying solar cycles with SDO, we can trace how shifts in magnetism affect temperature, weather, and radiation. The sun does not control our destiny, but it writes the background against which our story unfolds. Narrator. In the dance between sunlight and shadow, we find our equilibrium. The warmth that feeds our oceans, the storms that remind us of fragility, all are expressions of the same pulse of energy. Scene 7. The magnetic web. Beyond Earth, the solar wind continues its reach. It collides with Jupiter's magnetosphere, creating auroras 1,000 times brighter than our own. On Saturn, magnetic storms twist its rings. On Uranus and Neptune, the sun's breath still whispers, faint but persistent, shaping the edge of the solar system. Even the distant Voyager probes, now in interstellar space,
can still measure where the solar wind ends. They tell us where the sun's voice grows silent. And yet, that silence is not an end. It is the border between our star's influence and the greater ocean beyond. Scene 8. The Art of Seeing. Every image from SDO is both science and art. Filaments ripple like silk. Flares arc like brushstrokes across a glowing canvas. Magnetic loops rise and fall like waves frozen in light. What was once too bright to see has become something profoundly human, a reminder that beauty exists even in chaos. Each 4K frame is more than data. It's evidence of perspective, that we have learned not only to survive the sun's power, but to understand and admire it. Scene 10. The quiet between flares. For all its violence, most of the sun's life is peaceful. Calm light fills the solar system, warming planets, nurturing atmospheres, sustaining life. In these quiet intervals, SDO records the subtler patterns, waves traveling through the corona, ripples caused by oscillating magnetic fields. They remind us that even in stillness, the sun is never asleep. The same is true for us. In calm, we learn. In stillness, we reflect. Scene 11. Transition toward meaning. We have seen the sun's surface, its storms, its winds, and its gifts. But one question remains. What does it all mean? Why do we seek to understand a star we cannot touch? Why build machines to stare at something so far, so dangerous, so eternal? Perhaps the answer lies not in the data, but in what it awakens in us. The realization that to know the sun is to know the story of energy, life, and time itself. We followed the Solar Dynamics Observatory from its first orbit to its decade-long vigil, watching the sun's surface erupt, shimmer, and breathe. We've traced the light that leaves it, through storms, through space, through us. Now we stand at the edge of meaning, asking what the sun truly tells us about ourselves. Scene 1. The Watcher above the world. For more than a decade, SDO has never blinked. While we slept, it watched. While we turned away, it continued to record every pulse of light, every flare that reached across millions of kilometers. Its cameras have seen billions of eruptions, yet no two are alike, each one unique, a fingerprint of magnetism, a heartbeat of a living star. From its orbit, it sees what no human eye could ever bear to witness, and it transforms that light into knowledge. Scene 2. The Scale of Connection. When we look at SDO's images, we see patterns that echo across nature, whirls of plasma that resemble hurricanes, filaments that twist like DNA strands, bursts that spread like neurons firing in a brain. It's as though the sun itself mirrors the laws of life, from the microscopic to the cosmic. The same mathematics that governs a cell's division governs the loops of magnetic plasma on a scale millions of times larger. The same harmony of tension and release that makes music beautiful is written into the rhythm of solar storms. Narrator, softly. In the patterns of a star, we glimpse the architecture of everything, the structure of chaos, the order hidden in fire. Scene 3. The Human Reflection. Why do we watch? Why spend years staring into something that could end us with a single flare? Because the sun is more than a source of heat. It is our oldest teacher, showing us that power and stability can coexist, that energy is born from balance, that creation and destruction are not opposites, but partners in an eternal cycle. Through the SDO, we are not just observing a star, We are learning how to live. Scene 4. The scale of time. Every day the sun rises, and every day it looks the same. But over years, decades, centuries, its slow evolution becomes visible. Sunspots drift like continents. Magnetic fields flip like seasons. The corona brightens, fades, and brightens again. The SDO has captured more than images. It has captured time itself unfolding. It has given us a clock built from fusion, a reminder that even in apparent stillness, the universe is always moving forward. Scene 5. The legacy of light. Every photon that reaches us began its journey long before humanity existed. Yet here we are, building machines to follow its path back to its source. The SDO's legacy is not only scientific, it's existential. It teaches us that we are creatures of light. Our food, our climate, our breath, all trace back to fusion in the sun's core. We do not simply orbit the sun, we are extensions of it. Our atoms are energized by its radiation. Our days are measured by its movement. Our lives unfold in the warmth of its glow. We are, in a very real sense, the sun made conscious. Perhaps that is what draws us to look deeper, the recognition of something familiar. When we stare into the sun, we are staring into our own beginning. Scene 6. The light that thinks. There is poetry in the fact that sunlight, born in nuclear fire, became the energy that fuels thought. It grew forests, powered evolution, and gave rise to a species capable of curiosity. And now that same light is what SDO uses to see. A machine powered by the sun, watching the sun. Light observing itself, consciousness reflected back to its source. In that loop, the universe becomes aware of its own existence. Scene 7. The sun and the fragile world. From SDO's perspective, Earth is invisible, a small blue shadow moving between the sun and infinity. And yet every image it sends home returns to that small world, to us. We use that knowledge to protect satellites, to forecast storms, to power our homes, to understand how thin our shelter really is. Without the sun, there is no weather, no oceans, no air, no life. Without our awareness of it, there is no meaning. Scene 8. The future of the Watchers. SDO's mission continues, but its descendants are already on their way. The Parker Solar Probe, the Solar Orbiter, and new observatories that will fly closer than ever before. They will touch the corona itself, taste the solar wind at its source, and measure the very particles that power our sky. Each mission brings us closer not just to the sun, but to understanding the engine that drives every star in the cosmos. The SDO was the first true eye, but it will not be the last. Scene 9. The meaning of what we've seen. For more than a decade, the Solar Dynamics Observatory has shown us the sun in breathtaking detail, in colors our eyes can't see, in motions too fast to notice, in cycles too vast to comprehend. And yet its greatest gift is not data, it's perspective. Through SDO, we've learned that our sun is not a distant ball of fire. It's a living system, complex, creative, and connected to every atom of our existence. In its storms, we see energy. In its stillness, we see grace. In its constancy, we see home. If you could stand where SDO orbits and look down at the sun, you would see not danger, but beauty. You would see a star that has burned for 5 billion years and will burn for 5 billion more. And in that light, You might feel something deeper than knowledge. You might feel gratitude. Scene 10. The final thought. The sun will outlive us. It will outshine every city, every memory, every voice. But for a brief moment in time, a species on one of its worlds learned how to see it and how to understand. That is what makes the Solar Dynamics Observatory extraordinary. It is not just a satellite, it is the eye of curiosity, the proof that awareness itself can reach across space. And through its lens, we realize that the deepest we have ever seen into the sun is also the deepest we have ever seen into ourselves.